I'm Kiran Bondalapati. I'm the CTO and co-founder of ZeroStack, and I wanted to tell you a little bit more about. Ajay talked about the why and the what of what ZeroStack is doing. I want to go a little bit deeper into the how part of it, and we can go as deep as you want or as fast as you want, so we can get to the demos quickly. So the basic thing that we talked about is ZeroStack is a two-part. One is the on-premises ZeroStack cloud building blocks, and this basically has the Linux operating system plus a hypervisor, which we support KVM right now, and it runs OpenStack services and a few other services plus a ZeroStack control plane.
You said KVM right now.
Yeah.
That was kind of leading to something. What other platforms do you?
KVM is what we support right now, but our solution, as I go through the technology that we have built, it basically is our key IP is in the layers on top in terms of management. So we're not the ones providing value in KVM. So there is nothing preventing us from supporting future hypervisors in future.
Awesome.
The ZeroStack Cloud Portal itself is where we have built all the monitoring and events and alerting infrastructure together with processing the data to give you a lot of insights. Now, if you look at what the ZeroStack Cloud Building Block has, like we said, there's a Z block which has 4 hosts. Each of those hosts have storage in terms of both SSDs and hard disks. And this is the platform on which your workload is running. And that workload is, a complex set of applications running in different VMs. And the VMs that you see are the user workload. In addition to that, we have a small controller VM that is running on each of these hosts, which comprises the ZeroStack control plane. This is where most of our code is isolated. And what it really is doing is it takes the storage that is spread across all the hosts. It actually converts it into a clustered storage. So you actually get distributed storage fabric. And we also have a networking fabric, which is integrated to provide a software-defined networking. And we'll see demos of what sort of software-defined networks you can create, and you can get isolation between the networks. And you can provide your own soft routers to connect all these networks together. We'll see demos of this thing. Then the ZeroStack control plane itself is one of our key features that we built in terms of once you have a cloud, a lot of the time is spent actually in keeping it up and running. And that is where we've sort of started off from the ground level in terms of saying, how do you use software to keep this cloud up and running as opposed to people? So we want to be in the business of making sure that whatever services are running, whatever hardware is running, is all taken care of by the ZeroStack distributed control plane. And once you build this one out, like Ajay said, once you rack one Z block, as you put more and more Z blocks, the software and the control plane and all these seamlessly scales across all of these nodes. So your cloud grows seamlessly without you having to reconfigure or bring your cloud down or add more nodes into it. And like we said, the nodes can be any different variation of the cloud building block.
How much can it scale out to, just for example?
Right now, it's more based on limiting of what we can test, but there's the software design-wise, there's no limits. A couple of racks is something that we can, say right away.
So a couple of racks would be how many? 2
So that's about 80 hosts.
About 80 hosts. And you've tested up to 80 hosts, or this is the original? We
are in the process of doing it right now. And once we have this on-premises infrastructure that forms this ZeroStack control plane, this is continuously talking to our cloud gateway, which is sitting in our SaaS portal, and it sends events, health monitoring, and the statistics using the connection only HTTPS out 443. So we don't need any firewall ports to be opened back to talk to your cloud. It only, the cloud, the on-premises infrastructure reaches out and talks to our cloud. Let me talk a little bit more about what the ZeroStack control plane really means. Like I said, you want a non-stop cloud. You want things to be always up and running. To do this, you deploy your infrastructure, which it is typically your workload infrastructure. Then you end up having to deploy some other controller nodes within rack to monitor this thing, to collect information about what's going on. And you set up a system which is something fails, you get paged at 2 a.m. in the night, or on Saturday at your kid's birthday. This is where exactly the ZeroStack software is built to avoid all those things. What we do is we have a distributed set of software services that are running across all of these nodes. Part of the services are just our own, which are monitoring everything. Part of the services are the software services needed to provide a cloud in terms of compute provisioning, storage, networking services. All of these services are distributed across all the nodes in a load balanced manner. So effectively, your cloud gets even the workload that we are running to monitor your cloud is load balanced across your system.
So can you talk us through each layer then? So start off with a storage architecture. How you use the SSDs, how do you provide RAID or RAIN, whatever it may be, just to kind of let us know how each part's put together, really.
That's a great question. In terms of storage, what we do is we take the resources that are available across all of these nodes, both SSDs and hard disks, and combine them to provide you 4 different storage pools.
Okay.
One is just local storage in terms of high IOPS and high capacity local storage. And then we also have high IOPS and high capacity replicated storage.
Okay.
Now you can use this to run your workloads in different formats based on whether you want replication or not.
Okay.
You can pick and choose when you're picking. So we combine it into just make it as a 4 storage pools that are available. So you don't have to worry about how you configure all of this thing together. Now at an application and a user level, when you're consuming the cloud, you get to pick when you're creating a VM, creating an image, saying, oh, this runs on a replicated pool, or this runs on a non-replicated pool.
Is this a replicated pool within a single site, or are you talking replicated to a secondary site for
No, this is replicated across your cloud within all the hosts.
But in the
Right now, it is a single site.
Right now.
Yeah.
So, okay.
It's a single
Single
site
site.
replication.
Yeah. So you can basically choose your protection levels for your
Exactly.
VMs.
And this is based on, you're choosing the protection levels based on every time you provision a project, or is it based on when you...
So when you create each application or even a single VM, you can pick that.
Actually,
So-
it's very granular. You can actually, for a single VM, for every disk, you can say, I want it to be local or replicated. I want it to be on SSD or non-SSD.
So your
Sorry, go ahead.
I'm sorry. So your consumption model is completely taking OpenStack's consumption and you're provisioning infrastructure strictly based on OpenStack's consumption model. So from a infrastructure provider's perspective, the SDN, the storage, the compute, all that is consumed via my OpenStack API or consumption model.
Or the UI.
Exactly.
Or the ZeroStack
Exactly.
UI, yes.
So I've got a virtual machine which is replicated and protected because it's got n+1, for example. Let's say, where does that virtual machine data reside then? Because I'm assuming I could have the VM itself over here, but it's storage on this node over here, yeah? Is that correct? Am I
I
saying?
mean, so we do make it available as a storage pool. If you pick local, it can actually be local to the node.
Okay.
If you actually pick replicated, it is replicated to additional nodes too.
And then how do you deal with random reads based around that?
So the performance of that is a function of whether you are picking SSD or disk. If you
Okay.
pick SSDs, then random or sequential doesn't make any difference. And we have seen on our platform VMs getting 10 to 20,000 IOPS routinely. If you go to disk, I don't think anybody can help with random reads. A disk can do 100 random reads per second. Now, depending on how many disks you have, I think you'll be limited by a few hundred.
The replication, is that really replicating a pool? Or is it like with VMware vSAN that you can really say, okay, I need 2 instances of this VMDK, or this one needs 3?
So it's done more as on the pool level. So when you pick and create a volume, it is put on a pool which is automatically replicated. So it's on a...
It's really like replication between, for example, two data centers, as long as you build them as one site.
No, so right now it's sort of limited to only within the data center, within your cloud. In future, we're looking at replication across the sites too.
Yeah, and I think there we also have to decide whether it's a async replication, what granularity that you do, because if you have remote replication, you cannot do it synchronously. The performance would just be too bad. So then you may have to snapshot workloads or VMs periodically and replicate that snapshot. Yeah. But that is something which we haven't done right now. It's
Which part? Snapshots or the or async?
the async replication. Snapshots are built in right now. You can take snapshots of a VM even today.
Are they copy on
VM
write or
or of
redirect
the
on
volume?
write? You know?
Copy on write.
They're copy on write.
Okay.
So what is the SAN? Because obviously it's a software distributed storage, is it a Cassandra kind of thing? Is it a Google file system kind of thing?
It essentially gives you block storage. For example, on Cassandra, you cannot run VMs on Cassandra. I mean, it gives you an API.
We're using more of a key value store, not really as running your VM.
It's a block store.
It's a block store. It's something like Nutanix uses Cassandra as its underlying file system.
Nutanix, actually, no, because they use Cassandra as a key value store to track where the blocks are.
Okay.
But the actual blocks themselves live just on an ext4 file system.
Is this just Cinder? Is it just an implementation of like Cinder under the covers?
Actually, we use Cinder, but Cinder is the one which uses the block storage that we provide.
Okay.
Cinder is just more an API layer to consume the block storage.
So did you guys build your own file system and whatever for the underlying Z VMs?
So in terms of the underlying thing, we have architected our own storage layer. It's not that we have built everything from scratch there or written our own file system. We are leveraging some open source technologies to build the storage architecture underneath.
And have you included things like dedupe and compression yet, or is that on the roadmap?
It's on the roadmap, actually. We haven't included. We have been, I think the company is about 1 year and 3 months old, and I think we'll show you how much we have built. And it's hard to have all these features in.
As far as, kind of nerd knobs, we've been the theme.
Nerd knobs.
If it's not exposed through the OpenStack API, you're not exposing it to the user. So it's relatively, the infrastructure itself is relatively simple. You guys optimize for OpenStack, and the consumption is based on a generic type of OpenStack environment. And if there's requests or expansions to the OpenStack API, you'll expose that. But right now, it's whatever you can consume via API is how you can administer your environment.
Yeah, I think that's a good way to put it.
Think about it this way. We are basically trying to provide that simple API, like you said, in terms of creating volumes and picking a pool. What we have done is we kept the API simple in terms of here's a few pools, and the user gets to choose saying, here's the API to create a VM, create an image using pools. What we have done in the underlying layer is to make it simple to the user to say, oh, we have taken care of taking all the storage and making it available in these 4 different sets of pools. So you don't have to think through how to build each of these volumes and everything. And stepping back at a higher level, right? What we are really trying to provide is a way to run applications. It's not really trying to think of storage as much as really saying, look, you have a cloud that is running. The storage fabric is there underneath. The networking fabric is there underneath. The cloud services are running. Any random disk failing, any random host failing is not the thing that should bring an application that you have specified to have replication down. That's the goal, to saying the application should be able to run seamlessly while any of these failures are happening. And that's where the replication comes in. So we try to keep the API simple to provide that.
So we spent some time on storage so far. Can we move up to networking? Just talk to us about how you do that.
Networking is overrated.
So, I think in terms of networking also, we have our own networking layer. We are using Neutron APIs, obviously, but we have designed our own networking across this cluster. I would say some of these things, once Deep creates a cloud, he's going to do a live cloud creation, and he's going to go through networking and storage setup. How about let's go through that, and at that time, we can go a little bit deeper, okay?
I will actually show you examples of creating networks and the soft routing, soft routers and everything also. And coming back to once we said, we have this distributed control plane, which is managing the storage and the networking parts of and the cloud services. The simple thing is, how do we do it? We use standard distributed and consensus algorithms and layer our logic on top of it to provide this high availability of these cloud services. So we have a leader election algorithm that picks out of all of these hosts that are running the ZeroStack control plane, and that leader is responsible for making sure that all the services are running. If there is any failure, for example, in terms of somebody yanked the power cord on one of the nodes, then the leader detects the node that is down, and it computes what were the services that were supposed to be running on that node. It automatically figures out what is the best place to run all these services on other nodes, and it migrates them to the right place they're supposed to run. And this is all happening in software.
Yeah, and that host failure detection, is that both for storage and network?
It's for everything.
Everything.
It's for storage, network, cloud services, everything.
We are actually monitoring health of each service, not only just by looking, but actually pinging the service to make sure if the service hangs, even then we detect it and we fix it.
This is really saying your cloud, whatever forms building block for your cloud. And cloud doesn't mean just an API. Cloud means storage, networking, workload. Everything needs to be up and running all the time. So think of our view is the way to build a cloud is the way you think of AWS. AWS has outages too, but still, think of public cloud, right? Public cloud, you just use it, right? That's the API that a developer should be able to use on the cloud, and it should be done using software. Just like there's a big layer of software that is controlling millions of servers to provide you a cloud, even in every enterprise cloud should be able to use that same power. Just like Google runs 10,000 nodes or 100,000 servers across all their data centers, but the developers don't have to worry about what is keeping it up. That's exactly what the ZeroStack software is trying to do. Make sure the cloud is up and running, storage, networking, services, everything. Now you could...
Yeah, I missed the part about services because I have maybe I'm old-fashioned, but I have my hypervisor on the box and I have VMs running on it. So why do I need to fail over any services? What is a service on the?
The services are like the software services that are providing storage, networking, and the cloud API and everything.
I think a very simple.
But why do I need to fail that over to? Because if I read your diagram, then you say that host number one will run two services. Will run the services from host number one and the service of host number two.
Yeah. So think of it this way. Our control plane is a fully symmetric, no special babies anywhere, no special puppies in one of the hosts, which basically means that the services which form part of the cloud to build the cloud, including storage, networking, and everything, are load balanced and distributed, including like failover and high availability, where we run multiple instances of services in different nodes, just to make sure that your access is always available in terms of being able to access your API, being able to access your storage.
So not every host runs every service?
No.
Let me just give a very
services are running in different hosts.
Let me give a very simple example. If you look at OpenStack itself, let's say there are 4 services that we are running. Now those 4 services could be running on 4 different machines. We are not running all 4 of them on every machine. That won't scale.
Okay.
So now you're running 4 services on 4 machines and one machine goes down. In a typical environment, somebody has to come in, figure out what went down, which service was it, and then bring it back up. In our case, we'll say there was Nova running on this machine. This machine went down because of hardware failure. In few seconds, Nova would come up on some other machine automatically. So the cloud would heal in a minute or so.
What is an example of a service?
So Nova is an example of a service.
Nova is a compute API service, compute service.
Volume management or image.
So for example, when you want to, it's like think of it as if you want to deploy a VM, the compute service figures out, when you create my VM, it figures out, okay, what are all the hosts that are available in your cloud, figuring out what is the resources being used on all of these hosts, find the best place for your new workload to run. So that's the compute service.
From a functional level, is that running in the ZVM, or is that running on the Linux distribution itself?
So most of our services run in the ZVM. There are a few services which have to run on the host. For example, a KVM interface libvirt service actually runs on each host.
Okay.
But most of the other API services and everything run inside the ZVM.
And the ZVM is one VM on each host?
Yes.
ZVM.
But one VM in each node, they're all doing, the control plane is running across all of them, but the services running on each node are different. And the control plane is making sure of them.
But it's not that you put one service per ZVM?
No.
Okay.
It's a whole control plane.
Yes.
So also in a 100-node cluster, you may have ZVMs running, but some of them may not be running any service because you just don't have enough services to farm out to.
And not to get back too deep into the storage conversation because it's storage. The ZVM, is that writing directly to the storage? Does it have direct attach? Is it writing directly to the direct attach storage? So if I lose that ZVM instance, it comes back up, and then I don't have to, when I have to rebuild or catch back up to the replicated storage.
Good question, actually, very good question. The storage, each write itself is not going through the ZVM. The ZVM is more of the control plane. The actual writes are going straight through the host.
So I would
then
say
what's
another
handling the replication?
Yeah. So another thing I would say, ZVM is writing to. There is data that you don't need replication for. If the ZVM goes down, it was local data, you don't care. but there is data that actually needs to be replicated so that when service goes from one place to another, it may need access to that data. So there is data which is local only, and there is data which is actually replicated.
So
there
that
are both
storage,
kinds.
so ZVM isn't providing, it's the control plane, is not providing the data plane for the storage functionality that's handled at the hardware.
Exactly.
Within
That is at the host level.
The host level.
That's the host service. That's another example where we have to run something in the host to go direct I/O.
So when you're talking about local storage, is that then a VM with its storage just on a single local ZVM, not replicated anywhere? If that host fails, you've lost your VM.
Yes.
But I suppose traditional infrastructure people panic, but in this kind of OpenStack environment, well, you deploy another VM or a container or something like that, and it'll respawn.
Yeah.
So you're not concerned as much about replicating that storage data across a distributed RAID or RAIN kind of pool, because it's self-generating.
It's an application, right? Think about this: most of the workloads that are running into sort of an OpenStack or even a private cloud environment, not specific to OpenStack. When you start talking about cloud-based applications, you're running like a Cassandra, which is doing application-level replication of all its data. Right? People are running MongoDB in a clustered mode. People are running Cassandra in a cluster mode. Or if you're running a simple MySQL sort of a thing, then if you say, oh, I'm running MySQL, I want replication for this one, then you use the replicated pool.
Okay, so
if you're doing application level, where you say, oh, I'm in an application, I'm writing to multiple nodes, then you don't have to use the replicated pool, you use the local storage.
So on a per VM disk level, you can decide whether you need to protect that VM at a storage level or not.
Yes.
If it's not protected at a storage level, your OpenStack will deploy a new web front end, for example, and all that VMs on that host would die, but it's your orchestration layer at your OpenStack layer or your application level that does it. Okay.
Okay, so that makes sense to me, what Julian's talking about there and how you've explained it.
Good.
I want to understand what happens if you lose one of these services then, okay? So I lose my storage service, my network service, whatever it may be, yeah? That guy then has to spawn and restart somewhere else, yeah? That's downtime, yeah?
So the interesting thing is the distributed management that we're running is actually continuously monitoring every service at a very fast pace. Think of it like heartbeat sort of a thing.
Okay.
And then any service that needs to be available as an API service, we actually run multiple instances of these so that you can actually access them in a load balance fashion and in a failover fashion too.
So you don't have one on every single host. You have, for example, in a 4-node cluster, you may have two only. Two storage, two network. Yeah.
True. Exactly.
So
makes sense now. I was like, whoa, guys. Okay.
So the thing is, the layer that we've built basically understands all of these. And like I said, our goal is non-stop cloud.
Yeah.
How do you keep the cloud non-stop? You have to solve all of these problems. And the interesting part that we did was the way we built our whole distributed control plane is it's intelligent enough to take configuration information saying, for this service, I want at least out of n nodes, I need k services running. It makes sure they're always running. It picks the k nodes that it needs to run on. So out of 100 nodes, you say, I need this running on 10 all the time.
Yeah.
Then it makes sure that 10 run, any node goes down, it makes sure the 10th one comes up on a different node. Yeah. 2 go down, it makes sure it comes up. So I've written the service to make sure all of this is handled.
So on the election process then, what makes a host the optimal choice to be the leader of that particular service?
So we do load balancing for that.
Okay.
I mean, I spent years doing DRS and storage DRS. We have our own metrics. We look at CPU, memory, I/O, and then we figure out which service should run where.
So feel free to share those algorithms. That's fine.
My PhD was in scheduling algorithms, so we can talk for 5 years about scheduling sort of a thing. So both of us have, PhDs in solving these type of problems. But that is, the thing is, these things are already solved in figuring out the resource thing, but making the right decisions in it's standard algorithms in terms of saying, but how do you make sure the judgment call of what needs to run where, how, is the input that you're given?
Yeah.
The intelligence that you have to give into the algorithm sort of decides how the system runs. So it's not just like, we use all our technology to build the scheduling algorithms, but when we look at all these cloud software pieces that needs to run, storage, networking, and rest of the cloud services, we are using our algorithms and the intelligence to say, pick how to configure this, pick what is the configuration for storage, networking, and making sure how many of these need to run and where. Okay. This is some of the decision that's gone in.
Kiran, in the interest of time, I think, how about let's reach to the demo section sooner because we want you guys to not
build the cloud.
cut down on demo.
I know you guys love demos. So the same thing, sir, for example, we said, like, even if the leader goes down, we make sure that the rest of the systems automatically elect a new leader, and then the system continues to automatically rebalance the services, and everything continues to run.
What's WAL stand for?
It's a write-ahead log.
WAL. Yeah.
It's basically the leader can write something into the log saying, I'm going to do these 5 things. If the leader dies in the middle of it, now somebody else has to become a leader and pick up what the previous guy was doing. And that is a way to pick it up.
So this is a way so that anyone maintaining state, even if that state node goes down, the state itself is distributed for someone else to pick it up.
It's like a Facebook wall. I'm going to have dinner now.
Exactly.
That
is exactly
photo
true.
Of my dinner.
And I'm done with my dinner now. It writes that thing too. I mean, let's switch over to the other half of the ZeroStack Cloud platform, because we spent talking about the on-premises, and like we've shown, there's a lot of value in building on-premises clustered software. But we looked at the problem and saying, what about the rest of the infrastructure that is needed to keep your cloud up and running all the time, right? To do that, we've actually built a lot of infrastructure in our own private cloud, where it takes the information that is coming from this cloud, it analyzes it, it processes it, and stores it both in terms of persistent store, where we actually run batch processing like MapReduce algorithms to analyze this information. And we also have real-time streaming analytics to figure out something that's happening real-time. And we combine this to basically provide information about what's going on in your infrastructure, because that is one of the key problems people are always asking. I built my cloud, it's doing something, people are using it, but you don't know what's been going on, you want to know what's going on right now, and how it should evolve in the future. So basically what we built is a system which basically helps you decide on all of these aspects. And we'll show some demos of looking at the past and looking at the future, both of these. And this is one thing I want to point out is there's a lot of companies out there just building this part of it, saying, you send us data, we'll show you graphs on it. This is something key where it's not just graphing what's happening in infrastructure, it's actually analyzing, understanding, and digesting that information to provide you insights.